All right. Well, hello, everyone. Thank you for joining Did You Know, the ESCO HVAC show. You know, we spent a lot of time talking about new refrigerants. We've talked about the HFC phase down and a lot of changes that are happening in our industry. But we don't always talk about some of the refrigerants that are really moving into the industry that need a lot of education on, like CO2, right? So we have our real good friend of the industry, Trevor Matthews. How are you, my friend?
What is happening, everyone? How you guys all doing?
The refrigeration mentor.
That's it. I'm here.
Man, you have really moved into a special place in the industry, and you're another fellow bell ringer, right?
Crack that bell.
Oh my gosh, we have so much to talk about, so many things that are almost unaware in our industry. When we start talking about things like CO2, you know, CO2 is not a new refrigerant. One of our early shows, we did the history of refrigerants, and I traced, CO2 back into basically the Industrial Revolution when we started using CO2 for mass ice manufacturing, when we're getting away from harvesting ice. So CO2 is actually one of our original refrigerants. You know, we moved away when we got into these non-flammable, non-toxic refrigerants that were our original CFC classes. You know, the whole flammability, that was really what we were looking at. But we never forgot about CO2. CO2 has always been around. It's primarily been in the industrial applications, but we are now seeing CO2 moving all the way into our commercial refrigeration, as well as automotive air conditioning. And we even have CO2 heat pumps that are being manufactured internationally. We haven't seen any of that technology in the US that I'm aware of, but it's a matter of time before we start seeing different uses of CO2. Now, the questions that we get a lot is, isn't that high pressure? And how do I work on this stuff? Do I have to retool my van? Do I have to get all new tools and equipment? Well, even when we talk about things like our A3s, our R290s and 600s, we have to retool a little bit to work with those. They're a different type of refrigerant, but it's still just refrigeration, isn't it? Right? So I am super curious. I know your history, and I've not learned a lot about what pushed you into the CO2. So let's start off there, and then let's talk about CO2 systems and give everyone an understanding of how CO2 actually functions in our refrigeration circuits.
Yeah. Awesome. Well, thank you. Thank you, everyone, for having me. Really, it started, I started learning about CO2 about 7 years ago, but just before I started Refrigeration Mentor, I seen a massive need in the industry. Like
Yes.
I've been doing I've been training CO2 since 2014, 2015.
Wow.
And over the years, I could see when I was watching Europe, I was watching other places around the world, I've seen it growing consistently. Because
Yes.
it's not new. Like back in 2001, Japan started putting in their vehicles, right? And then Europe started putting in the vehicles. And then they had the EcoCute, which was millions and millions of water heaters back in the early 2000s.
Oh, wow.
We got over 5 or 6 or 10 million water heaters now. I don't know if it's that high, but at least over 5 million.
Pretty significant. Yeah. That's a lot of homes being affected in commercial buildings.
And I consistently see the direction it goes. I'm a technician background, and I know the struggles it is for us out there learning these new technology. Yeah. And I developed my business, Refrigeration Mentor, to help companies around the world learn about CO2 so they're comfortable and confident working on it. And that's what I do. I make it easy for people.
Man, you're a man after my own heart. Take these advanced technologies, these sophisticated systems, and just repaint them with crayons.
Yeah.
That's kind of what we do, right? At least the foundation, because we don't want you to walk into it going, man, I got to be an engineer to work on this stuff. Because too many of my first industrial and commercial systems that I worked on, I was kind of intimidated with because I didn't know enough about them. And then I was fortunate to have my own refrigeration mentor, which was my father-in-law at the time, who taught me the principles of, if you know how it works and you know it well, it'll show you what's wrong with it. When you get good enough to understand how the thing functions, you'll become a part of that system. And that's really what we're talking about with CO2. I mean, we're talking about refrigeration. We're talking about using a different refrigerant, but it's the system that people are struggling on because they've just not encountered it yet. So let's kind of dive into that. But also, we want everyone to let us know where you're chiming in from. You know, we got usually people from all over the world. I'm here in central Indiana. Trevor, where are you at?
I'm just outside Toronto, Canada.
Yeah, all right. How's the weather up there right now, by the way?
It's gorgeous. It's like 20 Celsius, 68 Fahrenheit out.
Nice. All right. So how did you get into CO2? Let's start there.
So the first time I worked on it once when I was a technician, I kind of walked through a few stores which were secondary systems. This is back in 2011, 2012.
Like grocery stores?
Grocery stores, commercial.
Oh,
Yep.
yeah. Okay.
So commercial refrigeration. And I've seen it, like I seen it there, but where I really started to learn for it when I was the national trainer for Copeland in
Mhm.
Canada. So I trained all around North America,
Yeah.
CO2, and trained thousands of technicians on CO2. And really, what it started there. That's where I really started to learn.
See
Really,
the
E-
need and the
Emerson and
engineering
Copeland did a great
side.
job training me. Like they gave me the
Yeah.
opportunity, but I crushed it. I went in there
Yeah.
and I learned every day.
Good.
I was spending evenings, hours and hours every night
Yeah.
studying, researching, learning to better myself so I can teach and help the other people out there. So now, not only am I teaching technicians, I'm teaching designers, I'm teaching end users, I'm teaching
Educators,
engineers
instructors.
and instructors. So,
Yeah.
and I've built a lot of curriculum around CO2 to really help others learn. I had to go back to school to become an educator. Like
Yeah.
I didn't just become an educator. I used to be like an introvert. I was very shy. I didn't like talking in front of people. Now I talk in crowds of hundreds and
Look at
hundreds and
you.
hundreds. And what I do is I like to be able to get that person to where they want to be in their life or their career. So this is why my
Mhm.
big focus is on the refrigeration industry to help people succeed.
Jeez. I'm so proud of you, man. That's exactly the stories we love to hear because it's a fantastic industry. And the classes and the depth of education they do at Copeland is, I can vouch for it myself. Till this day, there's my compressor teardown, right? From my very first class at Emerson when I got into education. It wasn't until I became an educator and I started learning from professionals like yourself who have dedicated their time to learning the technologies. I didn't know how much I needed to learn until I got to that point. So I have a ton of respect for where you've went. You've taken the time to do the education and now turned back to the industry. Let's get into CO2 and let's help people understand because I know here in my own area, I see a lot of grocery stores like Fresh Times and some of our emerging grocery stores that are going 100% CO2 system or at least primary CO2 systems. Well, what are we talking about when we get into CO2? Where do we start?
Okay. The first start, I actually trained a bunch of people today on CO2, and it was the first session. So I always dive into what is similar about it because we're always hearing
There
about
you go.
the high
Yeah.
pressures,
Oh
this
man.
dry ice, so much safety. You do this is more complex. Don't get me wrong,
Right.
but at the end of the day, it is a refrigeration system. And what you said earlier, where you learned from your mentor, you just need to understand how it works. My
Yes.
first thing in all my trainings, I walk through the systems itself. Where's the flow going? It's
Yeah.
like when you look at a refrigeration system in your house, you go to your domestic fridge.
Let's
Where's the
start.
flow going?
That's
You
exactly
know,
right.
you get the compressors down the discharge line, out to the condenser, to the metering device, to the evaporator. And that's where I start with CO2. You
Okay.
got to walk through it step by step, but you need to know some key terms and terminology that's different.
There you
For
go.
people that are in supermarket industry going into supermarket refrigeration, you're going to see more of this influx first. I see heat pumps out there now. I see air conditioning systems out there now with CO2 here in North America. But the thing is, most of this is targeting supermarket application or market application.
Right.
So you need to understand the terms. And the first thing that I usually start with is this graph. You want to understand this graph here. This is a graph from the Danfoss Cool Selector 2
Yep.
tool. If you
Absolutely.
haven't used it, if you're a teacher or trainer, you need that. You need Danfoss Cool Selector 2, one of many apps that I can talk about from all the big manufacturers, but you need this one. But this is how I start. This is an enthalpy diagram. On one side is pressure, on the bottom is enthalpy. Okay. And what you need to understand is a few terms. First term is the critical point. Do you know what the critical point is? And you don't have to, Cliff, but do you know what it
So
is?
this is the point at which our condensing starts to struggle, correct?
There you go. So
Okay.
great job. So the critical point is when you're above the temperature and pressure of the refrigerant. The critical temperature, the critical pressure. So I'll just draw on it and I'll show you exactly where it's at. So right here at this point right here, this is be your critical point. So anything above this point, so just say you run your system here, you got a system that runs all the way up to here. This is your compressor, okay? Here's your compressor. This is where your heated compression, have you go from your suction to your distribution. This is not the scale, but I push that pressure up there. My ambient outdoor is 110 degrees Fahrenheit, 40 Celsius, and my pressure is above 155 psig or 72.8 bar. I'm in transcritical. I'm in supercritical cycle. So our transcritical cycle, supercritical state. At this point, when we're above that, the refrigerant does not have a pressure-temperature relationship.
Right. We don't have a saturation capability of the refrigerant above that point.
Okay.
And
then, so this is one of the big differences. Every refrigerant has a critical point, but
Sure.
like for 404, it's over 150 degrees Fahrenheit. We don't have temperatures on the planet like that yet.
Not typically. I have one place over in Ohio I have to introduce you to sometime. It's a steel manufacturing facility where they wear wooden boots to go out and work on the condensers. We'll talk about that another day.
So we're above that critical point, right? So now we're in transcritical. Now it's a fluid. So we know that gas leaves the vapor leaves from the compressor, goes up the discharge through the discharge line, through an oil separator, not going to get in all the components. And then we hit something that we used to call the condenser. But now in CO2 world, we don't call it a condenser because we cannot what?
We're not changing state completely in this component.
Yeah, we cannot condense. It does not condense because it's a fluid at this point. So as we travel through this, what we call now a gas cooler, we only can cool the vapor.
Okay.
But as we travel along here, and so our gas cooler condenser would be right here. We'll say for an example, gas cooler / condenser. We only can cool the gas. So now when they design the system, we want to make sure like if the pressure here is 1200 PSI, the outlet of it now is 1200 PSI. We are trying to cool it down as much as possible.
Right. How do we cool that?
How do we cool that? How does your condenser cool, subcool?
We bring some media across it that is cooler than the state that it is in.
Attaboy. That's it.
Okay. All right. That's starting to make sense. Yeah. So
we get some fans running.
Yeah.
We're cooling that gas as it goes through.
Okay.
So these have to be designed properly, but all we're doing is cooling what is called a supercritical fluid at this point. And I might have said gas there a couple times, but it's a fluid. It's not a gas.
Right.
It's not a liquid. It's a fluid going through there.
Okay.
And so now we're cooling the fluid down as much as possible. Because this is where lots of people say, well, CO2 is not efficient. Well, basic system for sure. 10, 15 years ago, the systems that were built, they weren't as efficient. But now with new designs, new strategies, you can keep the system always in subcritical. And when I talk about subcritical, it's always below.
So it always has a saturation capability.
Yeah. So right now, like every supermarket system out there runs in subcritical.
Okay.
Okay, so 404s or 448s or 407s or 454s, whatever the refrigerant is, we're always running in subcritical. That's one of the big difference between CO2 and standard refrigerants out there. Okay, so we cool the gas. So when we leave down to drop leg, we're leaving that condenser where the refrigerant usually would be a liquid leaving the condenser. Now it's this cooler, high pressure cooler fluid. Right?
Okay. Get myself confused here. So we had to differentiate between liquid and vapor and now go with fluid.
Yeah. So when we're in transcritical, that's that's a good one. Fluid cooler, gas cooler.
Yeah.
So as we leave there down the drop leg, we hit a special device that's in a CO2 system versus a standard refrigeration system. But if you're in a supermarket and you work in Canada or any of colder climates in the US, there's usually a valve down that drop leg. And it's usually like an A8 or a whole back valve or valve. So when you're in the middle of the winter, that you can stack that refrigerant.
We can maintain that pressure. We can keep our head pressure up. Sure, absolutely.
So as we come down here, we have a valve right here. And this valve drops that pressure. So I got fluid coming in on the inside, high pressure, high temperature fluid. But when I come out of this high pressure valve, I got a mixture of liquid and vapor coming in.
Aha. So we kind of meter it a little bit.
So we drop all the way back down, and we'll just say right to here. So we meter into our receiver, which we call a flash tank here. I've been noticing over in Europe, they only call it a receiver. So they're ahead of us. So I'm going to try to start implementing receiver in here, flash tank receiver.
It'll make sense.
Because that's standard. That's what we're seeing now.
Okay.
And so as that liquid and vapor fly through that high pressure valve, as it's metered through there, we have vapor and liquid now coming in there. The liquid drops to the bottom, the vapor stays on top. Okay. And this is what we call flash gas or gas.
Mm-hmm.
And one of the things the more gas you have, the more you have to bypass. That means there's more load on these medium temp compressors.
Sure.
So in the middle of the summer, the systems have to do more work. The compressors have to do more work with getting not really any BTUs out of the system, because this cycle here would go like this, something called a flash gas bypass valve right here, to digest that gas. Okay, so now I'm digesting the gas. So the flash tank receiver can have good quality liquid going to all the cases.
To supply our metering devices at the cases. I mean, that's really all we're trying to do, right? In any type of a situation where we have a receiver, we have some kind of a separate container, some type of a headmaster. We're trying to maintain our system pressure, but allow for a solid liquid supply. Because if we mix liquid and vapor back to our metering device, we're losing our efficiency of our refrigerant, because we're not doing any work with vapor, right? We're doing our work when we're changing state. So we have to be able to get a solid liquid supply. So coming off from our flash tank, we're going to eventually get solid stream of CO2 liquid. And now we're going to start thinking about our system as a traditional refrigeration system. We're just going from the metering device back into the evaporator, back to the compressor.
Everything after that is all the same as what you're working on if you're working on supermarket.
Yeah.
There's more complexity to it because there's more controls and there's more things to see. But after that, it's going to be your same cycle. So it'll go like this, and then we go out here, and then we go back up to the compressor. The drawing's not to scale. It's kind of a mess on there right now.
Yeah.
But here's my metering device, and then you'll have low temp, which would go down here. This is a really low temp one.
Mm-hmm.
And one of the things about CO2, they call them transcritical booster systems.
Oh, yeah. I keep hearing that term.
Why do you think? Do you know?
Well, we got to be boosting some kind of pressure.
Mm-hmm. So here's our low temperature compressors now, LT compressors right here.
Yeah.
So our LT compressors, low temperature compressors, discharge into my medium temp suction.
No way.
That's a little different, right?
Hold on here. So we're two staging off from our rack. I see that. Absolutely. Okay. I've actually worked on some split system low temp racks that operated medium and low temp cases just off from pressure differential. So all we're doing is just readjusting the pressure. Wait, what kind of a suction do we need?
So
what it comes down to.
Yeah, exactly. So what's happening when the difference is that this point right here, I got four things there. Let's scratch this line out. Okay. But this point right here, I got low temp discharge.
Yeah.
I got my flash gas bypass valve, and then I got my medium temp suction from all my cases coming back to one point. So these medium temp compressors are taking all that load.
Yeah, why not? Okay, so I can have one high side system operating two separate lower pressure systems, our low temp and our medium temp racks, all from one looped system.
So the medium temp always needs to be running.
Yeah.
So this one's going to be running because you cannot discharge low temp into the medium temp if it's not running.
So do we see more unloading and variable capacity compressors on that medium temp rack?
To me, every supermarket rack in the world should have variable speed or digital on it.
Yeah, absolutely. At least stage one.
Unless it's staged properly with unless it's staged.
You mean it was designed properly?
Yeah,
what? Yeah. No, that doesn't happen in the real world. One of my jobs was I'd go into older grocery stores and I would retrofit, 2D, 4D, 6Ds with, digital unloaders for stage one, so I can balance out my, suction graphs. Just because of this, we have to have some variable capacity because that system is going to run. Somebody's going to run all the time. So how do we control it? You're right. Variable capacity, which going forward, we're all going to live in a world of variable capacity if you're not already there. So, I'm digging this quite a bit.
Yeah. And I'm jumping ahead of myself here, but basically when we talk about the transcritical cycle, we're above the critical point, and that's your medium temp compressors running.
Okay.
When When we get into subcritical cycle, it's going to be down below here. So everything we see today, okay? So this would be subcritical because we're not above the critical point.
Right.
This will be transcritical when we look on a diagram. This is above that temperature and pressure. But most of the year, in most of North America, if you look at it, when you get to lower states like Texas or maybe Arizona or Florida, where it's really high temperature all year round.
Yeah.
You're going to be running in subcritical. Northern states, most of the year, you're going to be running in subcritical. But there are cases where manufacturers want to push it into transcritical because CO2 gives the best heat of any refrigerant, probably
Heat
the
transfer
best
rates.
of any heat of any refrigerants.
Yeah.
So this is what's cool about it. Now we're actually moving energy. Yeah. And this is the way you got to think about any refrigeration system. This is really when it started to make sense to me, when I started not talking about making things cool.
Right.
We're moving energy.
Absolutely.
And what we do now in most of our system, we're wasting energy. We're throwing it to the atmosphere.
Yeah, absolutely.
So what's cool with this is that now more and more systems that I see, especially some of the manufacturers here in North America, but definitely in Europe that I'm working with.
Right.
They got so many cool things going on, and they're using almost as much energy as possible for the heat content with the least amount of power to create that heat energy and that heat movement, if that makes sense.
Oh yeah, absolutely. We start talking about energy efficiency. One of the benefits of us actually moving into lower GWP refrigerants is the actual capability of the refrigerants themselves. When we move into some of these lower GWP refrigerants, our natural refrigerants like CO2 and like our propane and isobutane, the performance of the refrigerant significantly exceeds some of our traditional refrigerants. Remember, we have went to things like CFCs and HCFCs and HFCs because of their non-toxic, non-flammable performance, not necessarily the energy performance. So many of these natural refrigerants that we're going to, we are gaining a significant amount of efficiency. Yes, we may have some higher pressures. Yes, we may have some higher flammability. But when it comes down to energy, which is going to be key for us going forward, that is one of our motivators, energy consumption to do work, right?
Yeah.
So,
and so the big thing is that there's lots of, I've been hearing both sides. Synthetics are more efficient. CO2 is more efficient. Ammonia is more efficient. At the end of the day, it doesn't matter. If it's not designed properly, it's not going to be efficient. At the end of the day.
I used to do a lot of site visits for new installations. So I did a lot of dealer onboarding for a major manufacturer, and most of the systems that I would go out and do a performance analysis of, it wasn't the system that was performing wrong. It was the installation of the system that was performing wrong. So I completely get it.
Yeah, and the big thing is that CO2 is not for every application.
No,
it's not for every application. You're going to have to use something different depending on, because there's going to be ROIs, cost analysis. I've been dealing with lots of end users, working with them, trying to come up with the best strategies for their, their fleet of stores. But the big thing is that if you need heat, if you need heat reclaim, if you need heating water, anytime you need to use extra heat, CO2 is probably one of the number one refrigerants to use to get that heat. Because you can now, I did a session yesterday on CO2 heat pumps. Yeah. You can get CO2 up to like 194, 190 degrees Fahrenheit. You need a pretty much gas boiler. No other refrigerant's going to get it that hot, No. And that's only on certain conditions, not all the time. You got to have the right conditions of water coming in, or you got the return water, and all depends. So it depends on the design, depends on
the capability of the system.
So it's not cut and dry all the time. People are like, oh, this is more efficient. This is more efficient. Well, depends on where. Are you putting it in Canada?
Yeah, exactly.
CO2 is going to be super efficient. You put it in Arizona, CO2 could be more efficient. But
depends on the system design.
Yeah. You got to add some ejectors maybe, which are not difficult. People are talking about ejectors and they're so hard. I went over to Europe a few weeks ago and they showed me and they walked me through and I'm like, they're pretty straightforward.
Yeah.
It's just we're thinking about it's so difficult. We need to change our mindset and get off of the way it was done before and learn how it's supposed to be done now. And that's the thing. Start to learn about how we should be doing it. And we're going to continue to evolve in refrigeration.
I remember my first heat recovery refrigeration system. I had a little grocery store in Trafalgar, Indiana, and this is 25 years ago, probably. And so I was just learning my rack refrigeration. I started in a small family refrigeration business. And so I walk into this grocery store. It was built in the 1980s, early 80s. And, I'm evaluating the racks, got a medium temp rack, low temp rack. At that time, it was originally that one was an R12 and a 22 medium. And as I'm looking at this R12 low temp system, I've got hot discharge gas coming off from my rack heading up to an air handler. And I went, wait a minute. Wait, we're doing true heat recovery off from our refrigeration system and reusing it for heating our structure, right? So if we can start implementing these processes into our buildings, it's all about, building structures, homes, businesses that are more energy efficient, utilizing our energy, exactly like you're talking about. How can I move my energy into places that I need it? We always talk about, comfort cooling. We take heat from a space where we don't want it and we put it to a place that we don't care about it. Well, what if we did care about it? And we started putting that into our brain and went, well, if I'm moving heat from a space, where do I need heat? Can I put it someplace else and reuse my energy so I'm not wasting energy? And so we think about the size of some of these commercial industrial applications and the equipment that goes into them and go, why don't we reuse our heat and put it into places where we would like for it to be, where we're already using other energy sources? So a lot of opportunity here in the United States, particularly.
Yeah, for sure. And the big thing is that I really think we need to learn a little bit more of what they've done in Europe and
Yeah,
implement more of that, because I still see we're years and years behind,
couple decades.
but we don't need to be,
Yeah,
because what we're going through, what I see a lot of the stuff that we're going through now, they went through that 10 years ago.
yeah, they've learned the heartaches.
And we need to, and I'm trying to help manufacturers and trying to help designers and users to kind of take those ideas and work with them there and bring this here, because it'll help everybody, because it's going to continue to evolve. 100%, our industry is going to continue to evolve. So I got a couple more points that I just put up there. Triple point you're going to hear about. So it's one of the things about CO2 is that it has a high triple point.
Okay.
What that means is that it will, at the triple point, below the triple point, with any CO2 liquid, you get something called dry ice, which is solid, liquid, and gas.
Yep.
Okay. So when you're charging a system, and when I talk to you, you got to do it safely. Your refrigeration professionals out there, you have to understand the safety. This is more important than anything that I ever train. I always talk about national safety codes, work safety codes. You always want to go home to your family.
Absolutely.
We work with high voltage, we work with chemicals, oils. You got to be
lot
safe.
of deadly influences around us.
So what we need to do is what I do, and especially in my CO2 programs that I do all the time, I got some coming up in November, is that I talk about this. Like, if you're going to do a system, install a system properly, right? Follow what the manufacturer says, or the engineers and the designers, and look at the codes and make sure you're following the codes wherever you're at, because it could be different.
Read the installation manual. Did you
can imagine? But even if you don't, you got to follow best practices first of all. It's no different though. It's no different than when you should have been pulling it down below 300 microns or 0.3 torr or whatever thing. You got to pull a deep vacuum. With CO2, you don't just put liquid in, kind of like we did with blends. Any refrigerant was blended was always, you got to use the liquid for fractionation and all this other stuff. With CO2, you have to start with vapor.
Okay.
And you start with vapor and you get it above the triple point. So depending on what manufacturer you talk to, they're going to say, 100 psi or 7 bar, and a lot of them will say 145 psi or 10 bar, and get the vapor in there everywhere in the system. So now you can add liquid.
Okay. Completely makes sense. So we're getting past that point of the potential for our liquid to become a solid.
That's right.
So we're just making sure that we're safely introducing it into our system. Just like if we were working with any refrigerant in a chiller, we have to make sure that we get it above 32 degrees in case there's any moisture still in the tubes of the system, so that we don't have the potential for freezing our moisture, our water. Same thing with our actual refrigerant. We just have to make sure that we don't get it below the point that it has the potential to become a solid below its freezing point. Okay. Exactly. I'm glad you said that, because that completely makes sense. I had seen triple point and I'm going, okay, I know 2 points of the system. Where's the third one at? And I'm like, and I talk about sublimation all the time, so I should know, but I didn't. So,
And the big thing is there's been a lot of talk even over the years. I've seen manufacturers. I even did it at one point talking about, oh, we got to worry about dry ice below, getting liquid in there and turning it dry. You don't have to worry. I talked to technicians who are working on hundreds of CO2 stores,
right,
and to make dry ice, you got to work at it.
right.
You got to work at it. You got to try real hard. If you do the proper processes, you're
Yeah.
not going to create dry ice in your system.
Okay.
So that's something you don't really have to worry about, but you got to understand the process. And that's what I talk about in my trainings all the time when I'm training trainers or I'm training technicians. You have to follow the right processes. And these are just some of the steps, that one that I just talked to you about.
Yeah. No, I love it, because when we talk about any type of refrigeration system, it's refrigeration. If we become comfortable with refrigeration, we're going to add separate components. We can work on a completely different piece of equipment. You can go work on an ice machine. You can go work on an automobile. You can go work on a chiller. And when you understand the fundamentals, the principles that you already know are the foundation. They're the building block to get you into that next step. So we're not talking about learning an entirely new industry, an entirely new skill set. We're talking about taking some building blocks, some modular education, and adding it onto our fundamentals if our fundamentals are square, if we have a solid foundation. And that's what you do. You bring the building blocks of CO2.
Yeah, I just try to make it easy and relatable, because, for example, the two main valves that everyone needs to know about is this one here, this high pressure valve, HPV. Okay, some people call it the magic valve. Try not to call it the magic valve. It's the high pressure valve. It's a metering device, a pressure reducing valve.
Sure.
We're taking high pressure and we're reducing it down. It could be 100 bar or 1450 psi, and we're dropping it down to 37 bar or 530 psi or 540 psi. We're reducing it. We reduce the pressure, reduce the temperature. This is one key difference. Another key difference is this flash gas bypass valve, this gas bypass valve. Okay. You got to understand how that's a difference, right?
So are we trying to separate the vapor off there?
So that's taking the vapor off. Bam! Look at that. You're almost an expert already. You're almost an expert. You're an expert already. You know what I mean? So you're taking the vapor off the top. So when I think, if anyone on here is from the supermarket world and been working on a lot of supermarkets, especially in cooler climates, you have two valves that you usually see on there. You could have an A8 and an A9. Pull back valve and a receiver pressure differential valve. Think about like that.
Yeah.
Okay. Kind of relate the systems you're working on today to there. Now, if you're in the lower states and you're not using any flooded systems or whole back valves, then okay, maybe you got to learn a little bit. But I try to relate it to what people are using already. They work a little bit differently, but in the middle of the winter, that high pressure valve works the same as A8. It's holding back the pressure so it doesn't drop too low to crash the rack.
Yeah,
I've done that before.
Yeah.
It's not fun.
I can imagine
a while to get it started back up.
When we had that real cold streak down in Texas, I wanted to get a hold of some refrigeration guys and go, hey, how many guys out there learned how to tarp a condenser this year?
Exactly.
But it's all because of things like this. We are in the business of we are in the business of manipulating pressures. That's all we do in refrigeration. We use different medias for it, but we're in the business of manipulating pressures. So we either pressure up with a compressor or a device to do that, or we pressure down to be able to control and manipulate our boiling points. And in this case, now we're talking about a couple different points.
Yeah. And so the biggest difference from a synthetic or standard rack today that's out there are about 3 or 4 different things. There's more controls.
Yeah.
Okay? There's more electronics. There's electronic valves. There's a TXV. Yes, it is a bit more complex, but you can learn it. Yeah. If I learned it and thousands of technicians around the world have learned it, you can learn it. And if you're a teacher and trainer, you can teach this stuff too.
Okay.
You just need to understand the process. That's the big thing.
Sure, absolutely. Okay. Let's talk about that for a minute. And actually, if you're sharing screen, we can share another one, or I can bring one up. I want to talk about some of these resources, because now that we're clarifying it, right? I mean, we're here to build this community of HVAC and refrigeration, our building science professionals, and there are a lot of resources out here, and you are like at the top of the
Oh, thank
scale
you.
for CO2 training. And so we need to talk about that, right? We need to talk about these resources for not just technicians, but for educators, because we are now having educators coming to, we see a lot of growth at the National HVACR Education Conference with people coming to look for information. It's the
Mm.
hub for education because we have so many things going on. Well, we think about our schools that are now looking at CO2 systems going, I've never worked on a CO2 system. And I'm not sure that that's the wrong one, Dan. You want to hop that off? That was from actually last week. There should be one in there for Refrigeration Mentor, though, for a QR. We look at CO2 and we go, there's not a lot of training out there. There's not a lot of formal opportunities. Let's talk about what you do for formal training opportunities and things that Refrigeration Mentor has besides just being a good looking dude in the industry giving awesome information.
Oh, I appreciate that. So any trainer, technician out there, even if you're engineer or designer, I do like quarterly courses, like a 4-week CO2 course, kind of like a crash course to get you really involved. So if you're a trainer and you're going to start training other people on it, I recommend doing that. I'm working on actually doing train to trainer courses for educators, building a program already. I almost have most of it done. And because what I'm doing is I'm working with some of the biggest contractors around the world, and I'm training their technicians so they can train the rest of their fleets.
Yeah,
Because my
absolutely.
goal is to train millions and millions of people.
Yeah.
And at Refrigeration Mentor, we have tons of CO2 content. You can go to my YouTube channel. I got over 80 CO2 videos from the top manufacturers from around the world. And if you know anybody who should be on it, let me know, because it's 81, I think 82 this week. Like I'm consistently on Monday, I'm doing CO2 stuff, or go on the podcast and listen.
Yeah.
But all this information what I do is I go and do research. I'm calling the manufacturers. I'm getting the manuals. I'm looking up the systems. I'm going and asking them, can I come out to site to see this stuff?
Yes,
I'm taking my own time and my own money and flying around the world.
I know
to
you're
learn
all
this
over the
stuff
world.
and share it with other people. And this is what it's all about, is how do you get better? You got to put the work in, and that's what I'm doing to better the industry.
I love it, man. And I see such a need for technicians. We talk about the shortage of technicians that we have right now. And yeah, that is an issue. But when you start introducing high-end technologies, remember, we're talking about generations that have grown up with technology, right? We're talking about generations that once they get their hands on something and go, not only can I work on something, but I can make a difference in the world. I can use less energy in this building. I can make this building more green. I can become a green technician by working on equipment and making sure that it's performing well and maintaining, simply by understanding how things work. So I see a growth in that. What do you see, and what are you seeing for CO2 growth internationally as well as here in the US? Because a lot of people, when we talk about CO2, they think, it's just only in industrial stuff. I see a little bit more than that. I'm sure you do.
Oh yeah. So it's gonna get very real big, and it's gonna continue to grow massive. US is the biggest market right now, and it's not gonna stop anytime soon. Like, we're gonna see regulations change. I get people calling me from Singapore, Asia, talking to people all over Europe, South Africa, Australia. I'm working with people all around the world, training people all around the world. Is gonna continue to grow. So the biggest market that's going to grow is market stores, supermarket stores, and small market stores. They're going to grow the quickest. Heat pumps are coming out very fast. There's a lot of electrification happening. We're going to see consistently that market growing. That market is going to grow, and it's going to continue to grow. But it's not, like I said, CO2 is not the only solution, but it's going to be one of the refrigerants that's going to grow the fastest, especially here in North America, because of regulations.
Yeah, absolutely.
And so my goal is to help bring people that knowledge. Like Coca-Cola, they got millions of pop machines out there that had CO2. I don't know if they're still making CO2, but they did it years and years ago. So it's not like it's new. I had Howe Corporation on, and they got CO2 ice flakers.
Oh, no kidding. Sure. Yeah.
You know what I mean? So
yeah,
it's not, and I'm just learning a lot of this stuff, right? So we're going to see the supermarket grow. I think there's 60, 70, 80,000 transcritical booster systems in the world. And we're going to see condensing units. Like every manufacturer I'm talking about, they're working on condensing units at this point.
Yeah,
they're working. Some of them are working on heat pumps. More right now, we're starting in industrial heat pumps for more of district heating. We're
Yeah.
going to see a
Oh,
lot
that's
of
a
district.
hot topic right
Yeah.
now.
So, but we'll see it to start to get into the smaller area, and what we need is more governments. This is how it helped grow governments to put money into these technologies to help the people out there, right? Because they're not cheap retrofits at this point, right? Because it's new technology, new controls, more of it. So over time, the price is gonna come down. We're gonna have more. You know what I mean? It's like anything.
Absolutely.
That very first TX valve that ever came out way back decades and decades ago, it costs a lot of money.
Oh, I can only imagine.
You know what I mean?
Yeah.
Now we go and they're probably still expensive, but they're not as expensive as they were 50 some years ago, right?
Sure, absolutely. And that's a good point, Tomas. A lot of our stores, I think about some of my, I was a mobile engineer for Meyer grocery stores. I worked on a lot of old ones and I did a lot of new store startups. And I've seen that transition over the last, 20 years of the sizes and the mobility and the capability of the system. So I know where CO2 is going and the capability that it has. Next week, Jason Obshute and I are going to be spending a lot of time talking about the technology transition where we look at the GWP of refrigerants. Like a lot of people, join us and they go, oh, these guys keep talking about these HFC phase downs there at ESCO, not realizing that the HFC phase down due to the Kigali Amendment is one thing, but you also have this technology transition rule that's going to be coming out with new equipment starting January 1st of 2025. In many applications, we're not even going to have the HFC capabilities to be able to run those systems. So those new systems are actually going to be looking at all of our low GWP options, and CO2 fits the bill on a lot of stuff.
And like I said, it's not the only one out there. There's going to be lots.
Yeah.
There's going to be, for a while, there's going to be A2Ls, there's going to be A3s, there's going to be CO2s, but they're going to low GWP refrigerants because that global warming potential is so high with the other refrigerants, right?
Yeah.
And as an instructor, you got to understand that. So for every, say, 2,000, I think 88 pounds of 410 that's released, so almost 2,100 pounds of released in the air, that's your GWP.
Yep.
For 1 pound of 410A, it's 2,100 pounds of CO2 you can leak.
Yep.
So I might have said that backwards, but
well, no, it makes sense when you say it that way because you're right. So when we talk about the global warming potential, we have 2,088 times of our 400 that we do with our CO2. Most of our GWP is based on comparison of CO2, right? That's kind of a baseline measurement. So because it's so low, so ideally we would be using CO2 for everything. We just haven't gotten there yet. We have a lot of transitions to make, and we're going to see a lot of different refrigerants. But I am here to tell everyone that the refrigerants that we currently know, especially our 400 series, like the 410s, 404s, are very high global warming potential refrigerants. We're going to see those not being allowed in most new applications in just over a year from now. So we have to look at all of our options, our A2Ls and our A3s and our low GWP CO2.
And it's all stuff that's learnable. All this stuff is learnable. We learned it, right? Everything I know is I learned it, and it's just I'm trying to learn it faster.
Exactly. And that's what we're here for. We're here to bring industry professionals that dedicate their lives to researching, to come to the community and share. It's kind of like raising a child in the village, right? We all grow into this village of HVAC and refrigeration. We find things that we're passionate about, and we get really good at certain things. There's no way we can all learn everything. We have to rely on the professionals from each aspect that dedicate that time and dedicate that work to learning as much as possible. And I highly, highly respect you and what you do in this side of the industry. So
Thank you.
Glad to have you here and glad to share that because even myself, I've learned a lot. I've been kind of brushing on CO2, but I've never worked on CO2 in the field. I got good at fixing stuff. That's why I like the field. There was always a supply of broken junk that needed somebody to take a look at, right? And so I got good at certain aspects of our work, but there are many aspects that I don't know very well, like my CO2. And I recognize the importance of CO2 going forward. So we still got quite a bit of time out here. For anyone has some questions that they'd like to dive a little bit deeper or some experiences. And if you haven't told us where you're chiming in from, let us know. We're very curious how far we're reaching in this world of HVACR.
See Bill Northrop's statement there. Everyone should go to Chilventa. 100%. I'm going to be there.
All right, tell me a little bit.
You should be there.
All right. So that's the European Refrigeration
So this
Expo.
is going to happen in Germany. It was in Nuremberg. I don't know if it's every year it's in Nuremberg, but my first time was last year, and by far it opened my eyes up to see what's coming to the world.
Yeah.
All the top manufacturers in refrigeration around the world. I think it's the biggest refrigeration show. I was like a kid in the candy store the whole time.
I know. I was watching you going, oh, man, he's having so much fun.
So it's amazing. I'm going to be there in full force this next year. So it's going to be October 2024. Start planning now. It's a year, 12 months away. You can every month save $500 if you can, and save up to go.
That sounds like a heck of a road show right there.
It's gonna be a lot of fun.
I got a lot of people to convince on that one.
Yeah. Well, this is it. This is how you learn. You go and you ask the experts, or any expo.
Yeah.
AHR is coming up. I'm going to be doing some podcasts. I'm going to do
Awesome.
a talk at this event. Go there and start meeting people, introducing yourself, building your relationships, building your network. And this is how you start to grow. You start to meet more people. And when you go, if you're a technician at these events, you're like, oh, well, it's, I'm not learning it. You go ask the questions. You go, most of the manufacturers have piles of people there, and like they're engineers and they're designers. And this is how you go and learn. That's how I learn. I go and I start picking their brain. I spend a couple weeks before I even go to these events writing questions down. Who do I want to see?
Absolutely.
Who's the people I want to try to connect with? And I build a list of it. I ask the questions. You don't just show up. It takes work to do this stuff. I try to have a strategy when I'm going to these events so I can best help myself to help others. You got to help yourself first to help others. And that's what I've been starting to learn.
Absolutely. We're going to see you at our conference this year.
Yeah.
All right.
I'm pretty sure. I hope so.
March 25th through the 27th. So that will be in Vegas. And we would love to have you there. There'll be lots of conversations on new refrigerants, new technologies. All of the best of the trainers of our industry will be gathering to share with you the opportunities. I had an email just this morning from a owner of a distributor, an HVAC distributor. And he said, hey, is this open for distributors? And I said, well, we want you there. We need our entire industry represented so we can all grow better together. That's why we gather here every week after week to talk about the changes, the opportunities that are out there. So man, lots of good stuff.
So a few more points on here. So big differences between CO2, so for the supermarket area versus what's going on out there with synthetics, is that you got a high pressure valve, you got a bypass valve, you got a condenser that could be a gas cooler depending on the temperature and the pressures running. Yeah, you're going to have the flash gas bypass valve going into your suction of your medium temp compressor. You're going to have your medium temp suction coming back to the compressor, and then you get your discharge of your low temp going back to your medium temp compressor. So there's a lot of uniquenesses, things that you got to learn about how the system runs. And like I said, this is what I talk about in my training programs, is you got to understand how this system works versus the systems you worked on before. Because before you worked on a medium temp rack, or you worked on a low temp rack, or a dual temp rack, but they were really two separate racks altogether, right? So just taking it, turning it, and thinking about it a little bit to where it makes sense.
Man. All right. Got my attention. I got to learn more now. I'm actually kind of hyped up. I'm quite curious to learn more about CO2 and plan a good site visit, even just to get out and take a look at some CO2 systems up close. So any contractors out there in the Midwest, Indiana, Ohio, Kentucky, Illinois, looking for someone to come right along and do a road show with you on some CO2 systems, give me a call. I would love to take up the opportunity. And while everyone's here, make sure to go visit Trevor, refrigerationmentor.com, run over to the YouTube channel, and make sure that you hit both of us and you subscribe to our channels and you turn on notifications, because if you do, then you'll get updated when all the content comes available. On Mondays, when Trevor puts out a new video, you go, boom, or something come up. On Thursdays, and we've got a show just like this one coming up, you go, hey, what are we learning about this week? There's a lot of things out there to learn.
You got to share this stuff. This is how other people find out about it.
That's
it. Share it on Instagram, LinkedIn, Facebook. Get to the Refrigeration Mentor website. Check out the courses. Take the courses. Yeah. If you want to learn, you got to take the courses.
There you go.
And you got to get involved, and that's it. And if you want to learn, anybody can learn refrigeration, but you got to put the work in. You put the work in, you're going to grow, and you can grow really quickly. I'm doing a course right now with almost 60 technicians on CO2, and man, these guys are just like skyrocketing
Soaking it up.
They're just learning so much, and they're just like, it makes so much more sense now when you explain it that way. And
Doesn't it?
that's the importance of having someone there that can coach them and teach them step by step. They know this stuff though. You know what I mean? They just need someone to explain it, because any good refrigeration technician who say works on supermarket right now, they can go and work on CO2 no problem. There's a bit more controls,
Right.
there's a bit more complexity, but if they understand the process of troubleshooting the way they've done it before, they're going to be able to work on CO2 no problem.
You know, I was doing a little bit of research. It's probably been 3 months ago. I was helping another social influencer friend of mine looking at comparisons of salaries, true salaries in comparison to what for what we were looking at for national standards, right? Comparing what people think you make in our industry versus what you can actually make. And when I got to the job listings for CO2 technicians, it makes you sit and go, that's a pretty good gig. There's a lot of money being offered for CO2 technicians. And really, when it comes down to it, it is a refrigeration technician that's learned a new refrigerant and some extra components.
Yeah.
So that's why I love this industry. You can go anywhere you want.
You can travel the world with it. I did. Why can't you? You can make as much money as you want. And even if you're not working on CO2, I did a podcast maybe 2 weeks ago on how to make more money as a refrigeration technician. Putting the work in.
Oh, is it out?
Bring in more value. Oh yeah, bring in more value to your business. You want to make more money. I'll tell any technician out there, you want to make more money, you bring your company more value. You make them more money, you'll make more money. You come up with different ideas. Like, you listen to the podcast, I can't remember if it was 150 or 151 episode, and talk about different steps. I know people making more money than the rest of their team because they bring a huge amount of value. Yeah. If you can save a customer $30,000 on their bill, and there's a retrofit that's done, and you make your company $50,000, there's some money in there for you. But you got to build this strategy. You got to put the work in. It's not like they just give it to you. You got to go out and size the stuff. You got to write stuff down. You got to go and call manufacturers and ask them what the pricing is and do the pricing yourself. And you're like, oh, well, that's the sales guy's gone. Well, let the sales guy get the commission then. You know what I mean? You got to put the work in. If you want to be the best, you got to put the work in.
Yeah. And it's out there. You know, the work is there. You're right. I mean, I've seen it myself. You can go wherever you want to go. You just have to have that motivation and the resources. And that's what we try to do, connect you. So make sure, reconnect with Trevor, dive into the programs that are available for you, and let's keep pushing forward. All right, everyone out there, last opportunity. We've had quite a few comments come in. This is your chance. Otherwise, you're going to have to meet up with Trevor at one of the conferences or come to one of his classes. All right. Well, I think we're going to go ahead and wrap it up. Trevor, anything else you want to cover? Well, we've still got a few minutes left.
Well, the thing is just continue to learn, invest in yourself, grow your knowledge. You can learn anything you want. Personal development, professional development to get you to the next level, whatever that is. Do just a little bit more. Do a little bit more than what you did yesterday, and you're going to grow to wherever you want and get to wherever you want in your life and your career. Check out Refrigeration Mentor. Head to the LinkedIn page, Instagram page, head to Facebook, wherever. Go to the YouTube channel. Just learn, get better, grow your knowledge to be the best at what you do.
Love it. All right, everyone. Well, we sure appreciate everybody joining us. We look forward to seeing you next week as we dive into some of the EPA technology transition rule that just got voted on and signed here a week ago, that is going to affect our industry in big ways and in every sector, not just refrigeration for industrial and commercial, but in the residential, all of our split systems, package systems. We're going to talk about how things are going to look differently going forward in just over a year. A lot of big changes coming. So we will see you next week on Did You Know, the ESCO HVAC show. And thank you, Refrigeration Mentor.
Thank you.